All right, so example 2. We're asked to find the first, second, and third differences of the polynomial ax squared plus bx plus c by filling in the blanks in the following table. So first off, we need to look at the type of function we're given. The polynomial here is ax squared plus bx plus c. That is a quadratic polynomial. Quadratic. All right. So here, I've given you the input values, the x values. I've given you the output values, the ax squared plus bx plus c. And just to remind you, we're getting the output values because we're plugging in 0 into my x values. For instance, I'd have a 0 for both my x values here. This would go away, this would go away, and I'd just be left with c. For the next one, I'm plugging in 1 into both of those x values. So we've got a times 1 squared, which is a. We've got b times 1, which is b. And then we have c all by itself, and that's where we're getting that. Same idea for 2. I can plug 2 into my x's, and we end up with a times 2 squared. 2 squared is 4. B times 2, and there's that 2, and then c all by itself again. And you're seeing how we're getting the output values. All right. So our job is to find the first, second, and third differences of the polynomial by filling in the blanks in the following table. So, again, we can subtract. And I'm going to subtract using the method I showed you in example number 1. So, a plus b plus c minus c. A minus nothing is a. B minus nothing is b. And c minus c goes away. So we just have a plus b. Next, we've got 4a minus a, which is 3a, 2b minus b, which is b, and c minus c goes away. Already we can see the first difference is not going to be constant because we have different items. So we need to continue this. 9a minus 4a is 5a. 3b minus 2b is b. There we go. We've got 16a minus 9a. 16a minus 9a is 7a. 4b minus 3b is b. 25a minus 16a is 9a. And 5b minus 4b is b. We're continuing with our second difference. Change my color. We've got 3a minus a, which is 2a, and b minus b goes away. 5a minus 3a is 2a, b minus b goes away. 7a minus 5a is 2a, b minus b goes away. 9a minus 7a, b minus b goes away. And we notice that everything is 2a. So we found our constant difference. We can write constant there. And again, continuing on after the constant difference just gives you a 0 every single time. So this table, since we're using a generic quadratic polynomial, is describing all quadratic polynomials. So anything in this table is also true for every single possible quadratic polynomial. So we can say that if the second difference is constant, the function is quadratic.